All right, let's talk about unit tests. No, let's talk about myself. Woo! Okay. So my name is Colleen Dunlap. I am a full stack developer. I attached my resume in the bottom right corner. Very full stack, very multi-talented. Just kidding. I'm mostly a back-end engineer. I work at a company called Hungry Root. We're a grocery and meal kit service, mostly grocery, but we have aspects of meal kitting for those of us who don't like to figure that out day of. If you're interested, you can scan that QR code and you should get $50 off your first order of $100 or more. I really like it. I use it. I also work on it. So maybe I'm biased, but I don't know. I like food and they give me food. I don't think it's too too biased, kind of a human necessity. I've been using Django since 2022 across quite a vast amount of jobs. I've been using Python since question mark. My first Python job was teaching girls who code at my university, to little kiddos, and it was really cool. This year, I recently became a Django contributor, or what they call an author, which feels weird to say because compared to the size of Django, I feel like I've written very, very little of it. But that's the cool thing about open source and community. I'm also a circus artist, so if you're into aerial acrobatics, fire performance, contortion, all those stuff, feel free to talk shop in the hallway after. Or if you think that sounds cool, I guess I could do a lightning talk later this week on it. Yeah, okay, cool, I'll do it. It doesn't take too much convincing to get me to talk about circus. It's a lot harder to get me to talk about software engineering, but here we are. Okay, I'm gonna get started now. All right, so what is a unit test? First off, has anyone written a unit test before? Wow, has anyone ran a unit test before? Okay, how many of you are confident that that test was the smallest unit of code that could possibly be tested and be useful? What? All right, totally fair. Side note, I really love that the keynote this morning was talking about season technologies and really hyping that up because I'm like, yeah, unit testing, really sexy, right? But it's super important. It's one of the topics that, software engineers use like every day. Every time you want to push a feature, you should be running unit tests. So I'm excited to talk about it. But yes, units of source code, they want to be tested on their own as individual components. This is opposed to a system or integration test that would test the entire system. And I think about unit tests as finding termites or bugs, pun intended, in a plank of wood before using that piece of wood to build a whole freaking house. Why unit test the code as opposed to integration testing or what have you? As I mentioned, it focuses on small units of code, which means it's very specific. They are identifiable, they are isolated, they provide fast feedback and TDD. So the nice thing about a unit test is determinism. It means it can be reproducible, repeatable. You should get the same result every time you run a unit test if you don't break the code that is running it. What I like about a unit test too is if something does go wrong, your unit testing framework generally documents where the error is, as opposed to an integration test where if you run your 5 + 5 function and all of you sudden you get 26, depending on how long that function, that program is, it could be anywhere. So you get really fast, specific feedback with unit tests. If you went to college for software engineering or are just familiar with the blogs, you can often hear about test-driven development, or TDD. It does not stand for tiers-driven development, despite common knowledge. It technically, at least first, was test-driven development, which means you write your tests first as kind of a planning methodology, and then you write the source code to make the test pass, and the test kind of sets up the requirements, the acceptance criteria, so you get feedback on whether you're designing your source code right. So when we unit test, what do we actually want to test? There's two kind of schools of thought. One is implementation and the other is behavior. So testing for behavior means we're testing for what does the code actually do. If we put X into as our input, do we get Y as an output? This is kind of like a black box. You're not worried about how the implementation, how the source code is getting the result. We just care that the result and the behavior is what we expect. Implementation, on the other hand, how does the code do it? So as opposed to a black box, we have a completely see-through box. And this would be a question like, okay, we put X in theoretically to get Y, but did we call become Y in order to get the Y? With implementation testing, you want to think, how often do you want to rewrite the tests? Because naturally, software engineering is complicated. That's why we all have jobs. That's why we get paid decent money to do things, because it's complicated and it's hard. And oftentimes, they say all writing is rewriting. I feel like that happens with code a lot as well. So as your source code changes, how badly do you want to rewrite the tests? Your strategy for coding often changes more quickly than requirements, ideally. But there are uses for implementation testing as well. One example of that is the N+1 problem. So here we have a little bit of Django code. The first one takes all of the orders, then in a query set, we traverse the query set, and then for each order, we get the customer. Under the hood, however, what's happening is we do a select from the orders, and then for however many orders you have, hopefully your business is doing well, so that's a crap ton, you're going to do a separate select query, getting the customer for that order. That's the N and the N+1. The 1 is the order, and then the N calls are the crap ton of customer select statements. However, there's another way to write this that is with select related. There's some couple other strategies, but basically you're doing a join, and then you have one transaction from the database. And as you traverse orders, no additional select queries because you got them all in that original database transaction. So unit tests are really great because this isn't super obvious, at least the way you learn to code like in your object-oriented classes. It might not be super obvious that this is calling a crap ton of queries on the top, but your unit test knows. And we're going to talk about the assertions that it can do to tell you. So there definitely is a purpose for testing for implementation as well. All right, mocking. Everyone asks who's the imposter, but no one asks how's the imposter. So mocking is a technique to isolate the code being tested from its external dependencies. It is good for the isolation part of the unit test. It is good for the determinism part of the unit test, making it reliable and reproducible. It's also helpful for triggering different scenarios. If you have kind of a decision tree code pathing function, you can use a mock to make sure that your unit test takes a certain path. And it's good for placeholders. As we said, you can test-driven development. Maybe you need to write a function before one of its dependencies has been produced. You can mock the placeholder mock and placeholder, that third-party dependency. It's also great for implementation testing. We have some assertions, assert called with, assert called once, which will ensure a certain object or function was called as your source code was executing. Here's an example. So say we have a function that takes in a random number. With unit tests, we like things to be reliable and repeatable. So random is not reliable and repeatable. They both start with R's. I get it, but they are different things. So what we can do is we can patch that random int function that get random int and square will call, set the return value to 5. So instead of actually getting a random number, random int always returns 5. And then we can assert that it always equals 25. And then you can also assert that that random int function was called. So we did get a random number, but we can assert that the implementation was correct. Setups class, teardown class. A lot of times unit tests cover a wide variety of partitions, so you might be using certain objects very often. It can get pretty repetitive. That's why unit test has setup class and teardown class. I think this should have been in my introduction slide, but Django test is, oh, never mind. We're getting to that. Haha. Okay. Adderall works really well until it doesn't, guys. Okay. So setup class, teardown class. Let's go back to what the slide is about. So setup class is a function that is ran once before all tests in a test case class. This is really good for things like seeding things that aren't going to change between each class or each test function, excuse me. Setup, however, is ran before every test in a test case. An example of that could be creating a fresh order for each test because you want a fresh order. And then teardown class, like setup class, is ran once after all the tests in the test case have ran, and teardown is ran after each test in the test case. So you can also see those at the bottom. Setup class and teardown class are class methods where setup and teardown get executed after each test. Factories are how we get test data. It's not the only way you can do test data, but it's a really great generator. What it does is it modularizes the creation of test data. It abstracts out unnecessary table details, and they also allow you to use subfactories to create relations. So if all of your orders have a customer, you can create an order, but then also in that factory specify creating the customer as well. We'll use Factory Boy during this talk. But an example of this is if you're testing a function's ability to process or charge an order, you probably don't care what that order is specifically populated with, just its total and status. So you don't actually have to set up those order contents. Here's some sample code. You can use the faker library within Factory to create things like fake names, emails, phone numbers. And there at the bottom, we have an example of a subfactory. The model, that's not necessarily a Django model. That's the data model you're specifying. Cool. All right, now do it with Django. This was the thing that I was gonna talk about when I started talking about something, and I was like, let's talk about the slide. So Django.test.test case, that is the standard Django test case that we all probably use, and it is a subclass of a unit test case. So if you see me using unit test in the example code, etc., that's one because that's what I use. So I'm selfish, and I agree that you should talk about what you know, but also because Django itself uses it. So here's an example of how you would take in the Django test case to create your own test cases. And as you see, we are using inheritance. So when we write our own setup class method, we are inheriting from the Django.test test case.setup class. All right, so let's talk about all the cool things we can do now that we are using Django and not fighting Django in our unit tests. So first up, we have setup test data. So like setup class, this is ran once per test case. However, in our setup test data, we create model instances, and all the model instances that are created in setup test data are rolled back after each test execution. This is faster than recreating the same model before every test case as setup does. I see some with a phone and they want to take a picture. Okay, I'm going to flip it now. All right, so without setup test data, we have the setup function. This gets ran every time we have a new test case. So if test inventory service, for example, had 50 test functions, it would get ran 50 times. We'd create and delete 50 objects. However, with setup test data, not only do we not have to write as many functions, but we will get that fresh order each time we run the test without having to without having to delete it, recreate it, delete it, recreate it, which saves us a lot of time. Django Model Factory. So this is a class in Factory Boy. Fun fact, Factory Boy originally was developed for Django and evolved to be framework independent, which I think is really cool. But Django Model Factory allows for more field types. So image field, file field are two examples. Those are fields that can be on a Django model. So it's really nice that Django Model Factories can do those. You also have the option to mute signals. So for example, if we have a pre-save function on order model, to make a customer object when a user places an order for the first time, we can mute the auto creation of a new customer so that the test customer uses a subfactory instead of the pre-save function. And you use that with a decorator, factory.django.mute signals. And here is our factory now that we are using Django Model Factory as the base class. So you can still use object notation. So app.order, you could import the order model from app.models, but you can also use the string notation as well. And then we get to use things like file field to create a file field. But what's cool about that is if in your testing you need to use that field in your testing, it behaves as a file field would. So you can read the file, export, etc., all of those functions. Same with image. Mocking. This is a cool little thing I learned in my research, but there is Django mock queries. So this is a separate library, and it creates mocked query set objects, which support query set operations, order by, filter, etc. But it's cool because they simulate ORM transactions without a database connection. So if you have a really expensive query, and that's not really the point of your unit test, you can use Django mock queries to mock that out. Also want to note, you absolutely can use mock in its standard sense with a query set. You can define a query set and then set that equal to the return value or the side effect of a mock, and use that just as well. What's special about Django mock queries is that it doesn't require a database connection. All right, so I'm going to put you all to work. So we have a case study, grocery subscription service. Maybe it sounds familiar. I talk about what I know. But We are going to design our own test plan, maybe write out some test cases. You can work with the people next to you. It is a conference. You can confer. Yeah, I don't know. Pun intended? Is that a pun? I think that's just Latin. Okay, so let's talk about the case study. We have some models. We have an order model, a customer, inventory, and product models. I have defined kind of some important parameters on all of those models in these little boxes. I want you to note the ... means there's a crap ton of other fields. But you can, use your factory knowledge to ignore those fields as you'd like. And we're going to write tests for 4 different functions. We have submit order, which is an API post. Validate order, which is a backend function to ensure order is sufficient. Charge order is a backend function as well, which communicates with a payment API. And ship order generates a shipping label via a shipping API for our fulfillment center to use. So I'm going to give you guys 5 minutes and you can talk amongst yourselves. Think about what factories you would use, think about what you would mock, think about what sort of functions you would write, what partitions you would write. Yeah, okay, break. Hello, it's been 5 minutes. I won't subject you to socialization any longer. But I did hear people talking, which is really exciting. I heard someone say mock, and I hope they weren't mocking me. I think they were talking about code. So I'm going to call that a win. All right. Assertions. So we have some special assertions that you can use in Django. This is by no means a complete list, but they are helpful. So assert contains. This takes in a query set and makes sure that it contains a specific object that you're looking for. Assert form fails. This is Django forms, so you're asserting that the form fails given a certain input or action, whatever you're testing, whatever your source code is, really. They also have, assert form not fails. I don't know if that's actually the name. I should have written it down. But I assume if they're testing for failure, we also test for success, because optimism. And assert num queries. This is what I talked about a little bit back with the mocking. Assert num queries. This is really helpful for testing n+1s. You run your source code and then assert, check how many queries were ran. Now, for more complex source codes, you might not want to assert an exact number of queries, but you definitely will want to kind of set a ballpark. So, for example, do you want your test to break just because you've added another table that takes one quick select statement? Maybe not. But do you want your test to break when you call crap ton orders? Yes, probably. So you can assert queries is less than as well. You can also assert queries are more than 1, but you can also use mocking functions for that. So assert num queries is definitely helpful for testing for implementation before things get out into the wide world known as prod environment. Serializers. So serializers are part of Django REST framework. They're a way of taking requests and translating those into models. But are you sure you want to call them in your unit test? Are you sure you want to test them in your unit test? Should your unit test fail because the model makeup changed on the model that you're serializing? So, case study example, submit order utilizes Django REST. One day we decide that the order model should have a rating field for the customer to rate after they received their order. Now, when we submit the order for purchase, they probably don't have a rating yet. Why would you rate something that you haven't even paid for? So do you want your serializer to fail because it doesn't have a rating field present yet? Or would you want to mock that serializer in order to kind of contain it? Decorators are really helpful. Martha approved. Had to throw in a picture of the internet's favorite interior decorator there. But these are code decorators. So you can put these on top of your test functions to make things a little bit easy peasier. One is override settings. This overrides the Django.conf settings. Modify settings. This allows you to prepend or append to certain settings, e.g. middleware. Django.test.tag tags. That allows you to tag a test, so you only ran it when that tag is present, or can filter out different tags during the test run. Isolate apps app label. This actually goes on top of any model created just for your testing purposes. So it creates a new app label specifically for tests. So if you create a model that's only to be used in tests, you can decorate it with isolate_apps, test app, for example. And then skip is a decorator for unit test. It skips, it skips. So if you want to skip a test, you can skip it under certain scenarios. There are two that are Django specific though. Skip if/unless DB feature. So since Django is uniquely tied to the database, you can skip tests under certain database configuration scenarios. Utilizing manage.py to invoke tests. Had to include a Dilbert comic here. I love my managers. I really do. All in good fun. But, it's Dilbert. It's a Django conference. I had to. But you can add these fun little arguments, options to your invocation of the test to make things a little bit easier. So Python manage.py test plus we have parallel. This allows you to run your tests in parallel. You just add an integer after parallel, and it'll create multiple DB instances and run your tests in parallel, making it faster. Keep DB, you would add this if you wanted to keep the test database after your tests have ran. It's nice for debugging. No input. This is what you would put on the end of a invocation if you did not want to be asked if you wanted to recreate the database. So if your unit test failed or you control-C'd out of your unit test run early, you can use no input so it knows to just recreate the test database instead of prompting you, do you want to create the database again? Because I don't know about y'all, but I've wasted minutes in my career thinking my tests were running and it was just waiting for me to tell it to recreate the test database. So helpful. Tag, this is how you would only run tests that have a certain tag defined. PDB, you might not need this depending on what test framework you're using, but definitely for PyTest, you would use PDB in order to utilize breakpoints, set trace, all that good stuff in your test run, and -K to run a single test at once. And extending test case. So the joys of object-oriented programming. If you're like us, I'd like to think we have a very healthy unit test suite, but that means that we have a lot of very healthy unit tests. Unit tests use objects and, every industry has the specific like models, data types that are going to get used a lot. You can extend test case to make your frequent use case efficiency a little more efficient. So here we have an example. We wrote base test case with customer. Basically, all this does is it overwrites test case and it sets up a customer. So instead of having to write our own setup test data functions using the Django test case, we get to just use base test with customer. And that also makes reading things a little easier, makes things a little cleaner, makes your job a little less repetitive. You can also include boilerplate test setup, settings, etc. in your extended test case. For example, if you want to not use cache. So if you want to silence the cache, you could do that in a extended test case. In conclusion, if you're not using unit testing, you should start. And if you've started, I suggest you work with Django and not against Django. If you want to keep in touch with me, that's my Medium blog. And in case you really enjoyed this talk and are hungry, that is, once again, my referral code for Hungry Roots. There is a QR code talk, and that's like either tomorrow or the next day. And that made me kind of nervous about putting QR codes in my slides. So I also included the links as well that you can just put into your little browser. Sweet. If you have any questions, I'll be sticking around. You can just come up to me and ask. I promise I'm friendly. And yeah, happy DjangoCon.